Drying definition. Drying is the process of removal of small amount of liquid, water, volatile liquid, moisture by application of heat to obtain a dry solid or solid product. In general, drying process involves two operations. First, heat transfer, second mass transfer. Drying and evaporations are relatively same term but are distinguished in terms of removal of water. Here are some differences between drying and evaporation. There are difference between drying and evaporation. In drying processes, the main operation usually carried out on solid material, example powders or products. Evaporation in the process, the main operation usually carried out on liquid materials, example solutions or products. Second, drying in most of the cases means the removal of relatively small amount of water from solids, and in evaporation includes the removal of large amount of water from solutions. Third, drying involves the removal of water at temperature below its boiling point. Evaporations involves the removal of water by boiling a solutions. Fourth point, in drying, water is usually removed by circulating air over the material in order to carry away the water vapors. Evaporation. In evaporation, water is removed from the material as pure water vapor mixed with other gases. Application of drying, preservation of drug products, preparation of bulk drugs, improved handling, improved characteristics, reduction in transport cost, purification of crystalline products, prevention of corrosion. Preservation of drugs. Drying is necessary in order to avoid deterioration. A few examples are blood products, tissue undergoes microbial growth, effervescent tablets, synthetic and semi-synthetic drugs undergoes chemical decomposition. Preparation of bulk drug. Drying is the final stage of processing. Example, dried aluminum hydroxide, spray dried lactose, powder extract. Improved characteristics. Drying produce material of spherical shape, uniform size, free flowing and enhanced solubility. Granules are dried to improve the fluidity and compression characteristics. They are essential for production of tablets and capsules. Viscous and sticky materials are not free flowing. Drying modifies their characteristics. Improved handling. Removal of moisture makes the material light in weight and reduce bulk. Thus, the cost of transportation will be less and storage will be efficient. If moisture is present, size reduction of drugs is difficult. Drying reduces the moisture content. Factors affecting rate of drying. Particle size, nature of material, nature of moisture in that bound unbound, surface area, initial and final moisture content, thickness of material bed, temperature, amount of moisture, nature of products. Theory of drying. In a wet solid mass, water may be present in two forms, bound water and unbound water. What is bound water? It is the minimum water held by the material that exerts an equilibrium vapor pressure less than the pure water at the same temperature. Unbound water, it is the amount of water held by the material that exerts an equilibrium vapor pressure equal to that of pure water at the same temperature. Unbound water exists largely in the voids of solid. Thus, in non-hygroscopic material, all the liquid is unbound water. So, bound water, that is hygroscopic material, water in fine capillaries, cells, fiber wall, physical interaction, contain bound water condition vapor pressure of wet solid is less than the vapor pressure of pure water. And in unbound water, non-hygroscopic material water is in void space. Contain unbound water, there is a condition vapor pressure of wet solid is equal to vapor pressure of pure solid water. Theory of drying can be discussed under two headings. First one is equilibrium relationship and second one is rate relationship. In equilibrium relationship, air of constant humidity and temperature is passed over the wet material. After long exposure, equilibrium is reached. Equilibrium moisture content, that is EMC, it is the amount of water which exert vapor pressure equal to the vapor pressure of atmosphere around surrounding it. Based on the condition of temperature and humidity, solid will either lose or absorb the moisture. When air is continuously passed over the solid containing moisture more than EMC, then solid lose water till EMC is reached. This phenomena is known as desorption. When air is continuously passed over the solid containing moisture less than EMC, then solid absorb water till EMC is reached. This phenomenon is known as sorption. So moisture is less. Free moisture content FMC, it is the amount of water that is free to evaporate from solid. FMC is equal to total water content minus EMC. Rate relationship. Rate relationship is observed by considering a simple model which mimics the condition of a dryer. In this model, wet slab of solid is considered and hot humid air is passed over it. The change in weight is determined by weighing the slab at different time interval and following calculations are made. Here is the percent loss of drying formula. LOD is equal to mass of water in sample in kgs divided by total mass of wet sample in kgs into 100. Then percent moisture content MC is equal to mass of water in sample divided by mass of dry sample into 100. Then drying rate is equal to weight of water in sample divided by time into weight of the dry solid. From the data obtained by the above experiment, graph is plotted by taking FMC on x-axis and drying rate on y-axis. The curve obtained is known as drying rate curve. So here is the FMC curves. Here is x-axis FMC and on y-axis drying rate. So from point the A to B, B to C, C to D, D to E. So in first, the time corresponding to AB represent initial adjustment period. During this period, the solid absorb heat and the temperature increase. At the same time, moisture begins to evaporate and thus tends to cool the drying solid. After some time, temperature stabilizes. Heating and cooling rate becomes equal. This temperature is equal to wet bulb temperature of the drying air and is referred by point B. So initial adjustment period in which the hot air passes in the solid bed, temperature increases, then evaporation happen. In this condition, temperature decreases. The time corresponding to B and C represent the constant rate period. The temperature remains constant and the rate of drying is constant. The moisture evaporating from the surface is replaced by water diffusing from the interior of the solid. The rate of diffusion is equal to rate of evaporation. The moisture content at the end of constant rate point C is referred to as a critical moisture point content, that is CMC. Third, The time corresponding to CD represent first falling rate period or unsaturated surface drying. During this period, the surface water is no longer replaced at a rate fast enough to maintain a continuous film on the surface. Dry spot begins to appear and the rate of drying begins to fall off. The point D is referred to as the second critical point. At this point, the film of surface water is completely evaporated. The time corresponding to DE represents second falling rate period. During this period, the rate of drying falls even more rapidly than the first falling rate. During this period, the rate of drying is dependent on the rate of diffusion of vapors of moisture to the surface of solid. Point E is refers to as the equilibrium moisture content. Fifth, beyond E, the drying rate is equal to 0. Therefore, temperature and moisture content remain constant. Beyond E, continued drying is waste of time and energy. The curves may have different shapes for different levels of moisture. If the drying is carried above the level of CMC, only constant rate period occur. Equation for drying theory. Drying process involves both heat transfer and mass transfer operations. It can be understood more easily if the film of liquid at the surface of material being dried. The rate of evaporation of this film is related to the rate heat transfer by following equation. dW by d theta is equal to Q by lambda, that is equation 1, where dW by d theta is equal to rate of evaporation of water per hour. Q is the overall rate of heat transfer, lambda is the latent heat of vaporization of water. The rate of diffusion of moisture into air stream is expressed by similar to heat transfer, while driving force is humidity difference. The rate equation is given as dW by d theta is equal to K dash A Hs minus Hg, equation 2, where K dash is the coefficient of mass transfer. It is not constant but varies with velocity of passing air stream. A is the area of evaporating surface, Hs is the absolute humidity at evaporating surface, Hg is the absolute humidity in passing in air stream. Factors affecting selection of dryers. First, property of material being handled, physical characteristics when dried, physical characteristics when wet, corrosiveness, toxicity, flammability, particle size, abrasiveness. Second, drying characteristics of material, types of moisture, bound, unbound, both. Initial moisture content, final moisture content, permissible drying temperature, probable drying time for different dryer. Third, flow of material to and from dryer, quantity to be handled per hour, types of operation batch or continuous, process prior to drying, process subsequent to drying. Product qualities, shrinkage, contamination, uniformity of final moisture content, decomposition of product, rate of subdivision, product temperature, bulk density. Recovery problem, dust recovery, solvent recovery. Facilities available at site of installation, space, temperature, humidity, cleanliness of air, available fuels, available electric power, source of wet feed, permeable noise, vibration, dust or heat losses, exhaust gas outlets. So classification of dryers, equipments for solids and paste and solutions. For solids there are granules, so convection, conduction and radiation. In convection, batch process, continuous process. In conduction, batch process, continuous process. in radiation IR lumps. Then batch process having tray dryer and fluidized bed dryer. Continuous process tunnel dryer, belt conveyor dryer, rotary dryer, turbo dryer. Conductions having in batch process vacuum oven, freeze drying, continuous process pneumatic dryer. Then paste, sludges, agitator dryer. In there are two, atmospheric and vacuum. Then in solutions, convection and conduction. In convection, rotary dryer, conveyor, tunnel. Conduction having drum dryer, pan dryer, rotary dryer, spray dryer. List of equipments used for drying: drum dryer, spray dryer, fluidized bed dryer, tray dryer, tunnel dryer, vacuum dryer, microwave, radiant heat dryer, that is infrared, rotary dryer and freeze dryer. Drum dryer, roller dryer, film dryer having a principle. In drum dryer, heated hollow cylindrical drum is rotated on longitudinal axis, which is dipped into solution to be dried. The solution is dried as a film on the surface of dryer and dried to form a layer. Dried material is removed with the help of knife. So here is the diagram of drum dryer construction. It consists of horizontally mounted hollow steel drum of 0.6 to 3 meter diameter and 0.6 to 4 meter length. Below the drum feed, pan is placed in such a way that drum dips partially into the feed. One side of the drum spreader and other side knife is placed. Storage bin is placed to collect the material. Working, steam is passed inside the drum. Drum is rotated at 1 to 10 rotations per minute. The liquid present in feed pan adheres to the surface of drum. Material is dried during the rotation of drum and collected in storage bin by using knife. Note: drying process in drum dryer complete in less than one cycle, so the time of contact of material with drum is only 6 to 15 seconds. Uses: drum dryer is used for drying solutions, slurries, suspension, etc. The product dried are milk products, starch products, ferrous salt, suspension of zinc oxide, suspension of kaolin, yeast, pigments, malt extract, antibiotics, glandular extract, insecticides, DDT, calcium and barium carbonates. Advantages: in drum dryer, drying time is less, only a few seconds. Therefore, heat sensitive material can be dried. Drum dryer occupies less space as it is compact when compared to spray dryer. As a thin film of liquid is formed on the large heating surface, rate of heat transfer and mass transfer are high. The product obtained is completely dried and it is the final form. Disadvantages: maintenance cost of drum dryer is higher than spray dryer. Skilled operators are essential to control feed rate, film thickness, speed of rotation and temperature. It is not suitable for solution of salt with less solubility. Tray dryer principle: in tray dryer, hot air is continuously passed over wet mass. Heat transfer takes place by forced convection. Construction: it consists of rectangular chamber. Here is a diagram of tray dryer whose wall is insulated. Trays are placed in the chamber according to need. Working: wet solid is loaded into trays. Trays are placed in the chamber. Fresh air is introduced through inlet, which passes through heater and heat up. The hot air is circulated by means of fan at 2 to 5 meter per second. Water is picked up by air and moist air is removed from outlet. During the cycle of drying, only 10 to 20% of fresh air is introduced into it and 80 to 90% air is circulated back. Uses: sticky material, plastic substances, granules mass, or crystalline material, precipitates and paste can be dried in a tray dryer. Crude drugs, chemicals, powders, tablet granules or paste, parts of equipments are dried. Example, in tray dryer, handling of materials, that is loading and unloading, can be done without losses. Tray dryer is operated batch-wise. Batch drying is used extensively in the manufacture of pharmaceutical for the following reasons. Each batch of material can be handled as a separate entity. The batch size in the pharmaceutical industry are relatively small, that is 250 kg or less per batch, compared with the chemical industries thousands kg or more per hour. The same equipment is readily adjusted for use in drying a wide variety of material. Valuable product can be handled effectively and efficiently. Disadvantages: tray dryer requires more labors to load and unload. Hence, cost increases, process is time consuming. Tunnel dryer. This dryer is variant of tray dryer. In this type, trucks are loaded with wet material at one end of tunnel. This tunnel comprise of a number of units, each of which is electrostatically controlled. The solid get dried and the product is discharged at the other end of the tunnel. Spray dryer principle. In spray dryer, the fluid to be dried is atomized into fine droplets which are thrown readily into moving stream of hot gas. The temperature of the droplet is immediately increased and fine droplet gets dried instantly in the form of spherical shapes and particles. So here is the diagram of spray dryer. So with the help of cyclone separator, vapors and dry product are separated. Construction of spray dryer. It consists of large cylindrical drying chamber with a short conical bottom made up of stainless steel. Di Diameter 2.5 to 9 meter and height 25 meter or more. An inlet for hot air placed in the roof and another inlet carrying spray disc atomizer is also set into the roof. The spray disc atomizer is about 300 mm in diameter and rotate at a speed of 3000 to 50,000 rpm. The bottom of dryer is connected to cyclone separator. Working. Drying of material in spray dryer involves three stages: atomization of liquid, drying of the liquid droplet, recovery of the dried product. In atomization of liquid, the feed is introduced through the atomizer either by gravity or by using suitable pump. Then second is drying of liquid droplet. Fine droplets are dried in the drying chamber by supplying hot air through the inlet. Recovery of dried product. Centrifugal force of atomizer drives the droplet to follow helical path. Particles are dried and collected at the conical bottom. All these processes are completed in few seconds. Particle size obtained is ranging from 2 to 500 mm. Maximum size of spray dryer has a capacity of 2000 kg per hour. Uses. Spray dryer are used compulsory if the product is a better form than the obtained by any other dryer. The quantity of material to be dried is large. Product is thermolabile, hygroscopic or undergoes chemical decomposition. Advantages. Spray drying is a continuous process and drying is very rapid. Drying completes within 3 to 30 seconds. Labor costs are low as it combines the function of evaporators, a crystallizer, a dryer, a size reduction unit and a classifier. By using suitable atomizer, the product of uniform and controllable size can be obtained. Free-flowing product of uniform spheres is formed, which is very convenient for tableting process. Fine droplet form provide a large surface area for heat and mass transfer. Product shows excellent solubility. Either the solution or suspension or thin paste can be dried in one step to get the final products ready for package. Then it is suitable for drying of sterile product. Reconstituted product appears more or less similar to the fresh material. Globules of an emulsions can be dried with a dispersed phase inside and layer of continuous phase outside. On reconstitution, emulsion will be formed. Disadvantages: spray dryer is very bulky, height of 25 meters and diameter of 9 meters, and expensive. Such a huge equipment is not always easy to operate. The thermal efficiency is low as much heat is lost in the dispersed gases. Fluidized braid dryer principle: in FBD, hot air is passed at high pressure through the perforated bottom of the container. The granules are lifted from bottom and suspended in the stream of air. This condition is called as fluidized state. The hot gas surrounding even granules to completely dry them. So here is the diagram of fluidized bed dryer. Constructions: FBD is available in two forms: horizontal FBD and vertical FBD. The dryer is made up of SS, that is stainless steel or plastic. A detachable perforated bowl is placed at the bottom of dryer, which is used for charging and discharging of material. A fan is mounted in the upper part of circulating hot air. Fresh air inlet, pre-filters and heat exchangers are connected serially to the required temperature. Back filters are placed over bowl of for recovery of fines. Working: the wet granules to be dried are placed in detachable bowl and bowl is placed into the dryer. Fresh air is allowed to pass through free filter, which subsequently gets heated by passing through heat exchanger. Hot air passes through bottom of bowl and fan is allowed to rotate. The granules rise in the container because of high velocity gas, latter fall back in random motion. The gas surrounded every granules to completely dry them. The air leaves the dryer by passing through back filter. The entangled particles remain adhered to the inside surface of bag. Periodically, the bags are shaken to remove the particles. The material is collected after some time so as to reach the ambient temperature. Uses: for drying granules, it can be used for drying, mixing and granulation process. It is modified for coating of granules. Advantages: FBD require less time to complete drying, that is 20 to 40 minutes compared to 24 hours of tray dryer. Handling time is also short. It is 15 times faster than the tray dryer. It is available in different sizes with the drying capacity ranging from 5 to 200 kg per hour. The drying containers are mobile, making handle simple and reducing labor cost. The thermal efficiency is 2 to 6 times than tray dryer. It is also used for mixing an ingredient and mixing efficiently is also high. Hot spots are not observed in the dryer because of its excellent mixing and drying capacities. Higher drying temperature can be used that are not possible tray dryers and truck dryer. It facilitates the drying of thermolabile substances since the contact time for drying is short. It can be used either as a batch type or continuous type. It has a high output from small floor space. The free movement of individual particles eliminate the risk of soluble material migrating as may occur in the static bed. Disadvantages: some organic material may develop electrostatic charge, so requires earthing. Due to attrition, fines are observed in large quantities. Vacuum dryer principle: in vacuum dryer, material is dried by the application of vacuum. When vacuum is created, the pressure is allowed so that water boils at lower temperature, hence evaporate faster. Construction: it is made up of cast iron heavy jacket vessel. The enclosed space, that is approximately 1.5 meter cube, is divided into the number of portions by means of 20 hollow shells which are part of jacket. These shells provide large surface area for conducting of heat. Over these shells, metal trays are placed. The oven is connected to vacuum pump by placing condenser in between. Working: material to be dried is placed on trays. The trays are placed on shelves and pressure is decreased up to 30 to 60 kilopascal. Steam or hot air is supplied into hollow space. Drying of material is done by presence of vacuum. Water vapor passes into the condenser where it is condensed. At the end of drying, vacuum line is disconnected and material is collected from trays. Uses: vacuum dryer can be used for drying of the following: heat sensitive material which undergoes decomposition, dusty and hygroscopic material, drugs containing toxic solvent. This can be separated into closed containers. Feed containing valuable solvent. These are recovered by the condensation. Drugs which are required as a porous end products. Flyable dry extract. Advantages: vacuum dry provides large surface area for heat transfer. Handling of material, trays and equipment is easy. It is easy for switching over to the next material. Hot water desired temperature can be supplied. Electrically heated hollow shelves can be used. Disadvantages: in vacuum dryer, heat transfer coefficient are low. It has a limited capacity and use for batch processes. It is more expensive than tray dryer. Labor and running costs are also high. Sometimes there is a danger of overheating as the material is in contact with steam heated surface for longer period. Freeze dryer principle: in freeze dryer, drying water is removed from the frozen state by sublimation, direct change of water from solid into vapors. Constructions: freeze dryer, it consists of drying chamber in which trays are loaded, heat supply in the form of radiation, vapor condensing or absorption system, vacuum pump or steam jackets or both. So here is the schematic diagram of freeze dryer. Working: it involves the following step: preparation and pre-treatment, pre-freezing for solidifying water, primary drying in which sublimation of ice, secondary drying removal of residual moisture, packaging. Preparation and pre-treatment: the volume of solution introduced into the container is limited by its capacity. So, the satisfactorily freeze drying beyond a certain limit of depth of liquid is not possible. Therefore, pre-treatment is essential. The solution is pre-concentrated under normal vacuum tray drying. This produces a actual drying by 8 to 10 times. The final product becomes more porous. Liquid or solid desiccant are also used for this purpose. Prefacing to solidify water. Vials, ampoules or bottles in which aqueous solution is packed are frozen in the cold shelves about -50 degrees Celsius. During this stage, cabinets is maintained at low temperature and atmospheric pressure. The normal cooling rate is about 1 to 3 Kelvin per minute, so that large ice crystals is relatively large holes are formed on sublimation of ice. This is also responsible for giving a porous product. Then primary drying. Sublimation of ice under vacuum. So in this step, the material to be dried is sprayed as much large surface as possible for sublimation. The temperature and pressure should also below the typical point triple point of water, that is 0.0098 degrees Celsius and 0.533 kilopascal, 458 mm of Hg for the sublimation when water alone is present. Vacuum is applied to the tin of about 3 mm of Hg on the frozen sample. The temperature is linearly increased to about 30 degrees Celsius in a span of 2 hours. Heat is supplied which transfer as latent heat and ice sublimes directly into the vapor state. The heat controls the movement of ice layer inward. It has to be controlled in such a way as the drying process, thickness of frozen layer decreases and the thickness of partial dried solid increases. Primary drying stage removes easily removable moisture. During this stage, about 98% to 99% water is removed. Still traces of moisture is present in the sample. Secondary drying, removal of residual moisture under the high vacuum. During this stage, traces of moisture is removed. The temperature of solid is raised to as the high as 50 to 60 degrees Celsius, but vacuum is lowered below that. It is used in primary drying, that is 50 mm of Hg. The rate of drying is very low and it takes about 10 to 20 hours. Packing. After vacuum is placed, replaced by inert gas, the bottles and vials are closed. Uses. The freeze dryer is most commonly used in the production of dosage form such as injection solutions or suspensions. It is used for drying of a number of products. Blood plasma and its fractional product, then bacterial and viral cultures, human tissues in which arteries and corneal tissues, antibiotics and plant extract, steroids, vitamins and enzyme. Several other products such as food items, that is prawns, mushrooms, meats and poultry products. Coffees and tree concentrates and citrus fruit juices are dried. Advantages. The entire operation is carried out well below the freezing point. This offers several advantages. Thermolabile materials, that is heat sensitive materials, can be dried. The product retain its bulk volume. It is the porous and uniform. The reconstitution of material is easy. Denaturation does not occur. Migration of salt and other solutes does not take place. Loss of volatile material is less. Moisture level can be kept as low as possible without decomposition. Material can be dried in its final container such as single dose or multiple dose vials. Sterility can be maintained. The final product can be stored at an ambient temperature if well sealed by providing inert atmosphere. Disadvantages. The product is prone to oxidation due to high porosity and large surface area. Therefore, the product should be packed in vacuum or using inert gas or in a container impervious to gases. Equipment and running costs are high. It is difficult to adopt the method for solution containing non-aqueous solvent. Last one is the period of drying is high, rarely less than 10 hours. Time cannot be shortened. Thank you.